Centrifugal pump tutorial number 4. The inlet and outlet impeller diameter of centrifugal pumps are 200 mm and 400 mm respectively. Impeller width at inlet and outlet are 15 mm and 8 mm respectively. Blades are backward with angle of 38 degrees. Pump operates at 1500 rpm. The flow rate is 15 liters per second. Determine the pressure changes in the impeller. Assume there are no energy losses. So first you need to draw the velocity triangle. So because to simplify this calculation, so I assume that there is no whirl velocity at the inlet. So the velocity triangle at the inlet will become like this. And the velocity triangle at the outlet will become like this. And the angle 38 degrees is lay at this side. And this is all the information that we get from the question. So we need to change the liter here into the meter cube per second. So please be careful when you convert the liter per second to meter cube per second. So 1 meter cube is equal to 1000 liter. So the pressure changes is P2 minus P1. So our assumption is V1 is equal to 0 and V1 is equal to VF1. You could get this assumption in the velocity triangle at inlet here. And from Bernoulli equation, we could say that because there are no energy losses, so we don't put any major loss or minor loss in the Bernoulli equation. So we could say that the manometric head and the Euler head is equal to 0, is equal, so mean there are no losses. So we could say that P2 minus P1 over rho g is equal to V1 square minus V2 square over 2g plus Euler head. And then Euler head can be calculated by using this equation. So we have discussed this in previous notes, and we could simplify it because the value of V1 here is equal to 0. Euler head will become 1 over g U2 V2 like this. So and then we could calculate U and VF by using the equation. So this is the only two parameters that can be calculated by using fixed equations. So we could calculate U1 by using pi d1n over 60, U2 pi d2n over 60. We substitute the value, we get U1 is 15.7 meter per second and U2 is 31.4 meter per second. So we could calculate VF by using the idea of flow rate divided by the area, and the equation will become Q over K pi dB. So for VF1, we use D1 and B1. We substitute all the values, so we get 1.6 meter per second. And for VF2, we do the same things. So we get the VF2 is equal to 1.5 meter per second. So then we need to prepare the velocity to be substituted in Bernoulli equation. So we must remember that what we calculated here is U1 and VF. U and VF here is the component velocity. So the component velocity cannot be used in Bernoulli equation. In Bernoulli equation, we need to use the absolute velocity only, because the absolute velocity is the actual velocity that flow inside and outside the pump. So please bear in mind that in Bernoulli equation here, we need to use the absolute velocity. So we need to calculate what is V1 and what is V2. Luckily, in the inlet here, because the V1 here is equal to 0, so the value of V1 here is equal to VF1. So we could say that V1 is equal to VF1 and it is equal to 1.6 meter per second. Now we need to calculate V2. according to this triangle, we could say that from the trigonometry rules, we could write V2 square is equal to Vf2 square plus Vwll2 square. So we need to calculate what is Vwll2 because the value of Vf is already calculated in previous slide, so we could use that later on. And then we need to calculate what is the value of Vwll2. So the idea of Vwll2 can be calculated by using this equation. So you could derive this equation from the idea of tangent 38 here. So we play around with the equation. We could write Vwll2 is equal U2 minus Vf2 over tangent 38. So we substitute with all the parameter here. So we could get Vwll2 is equal to 29.5 meter per second. So we substitute into this equation. So we have Vf2 square. So we have Vf2 square, 1.5 square here. We have Vwll2 square, so this is 29.52 square, and then we have 872.5 meter square over second square. So, and then we could calculate the Euler head by using this equation. We substitute the value of U2 and Vwll2. So we get it is around 94.4 meters. Then we could calculate the pressure change by using this equation. So we bring the rho g from the left to the right side because we want to calculate the pressure only, not the pressure head. If we calculate P over rho g, that is the pressure head. So the answer must be in meters. So the question asks us to calculate pressure. So the unit must be in Pascal or kilopascal. So, and then we substitute the value of V1 square and V2 square. So we solve this equation. We found that the pressure difference or pressure changes P2 minus P1 is equal to 491.1 kilopascal.